So in this tutorial we're going to be covering searching and plotting. So this is tutorial number 5 under the beginner workflows tutorial folder. And we're going to start, as we did in the previous tutorial, by just creating a temporary directory to store the object store in. We're then going to retrieve some example data from the example data repository on the OpenGHG GitHub organization. This just downloads 2 tar files from containing Tackleston and Billsdale data. So these are just short example data sets that can then be processed using the process obs function. And this just returns a Python dictionary telling you where the data has been stored. So these are just unique IDs of the data sources and where the data has been stored within the OpenGHG object store. And then once all that data has been standardized and processed and stored in the object store, which in this case is local to your computer, we can then search the object store using the OpenGHG client search function. And this then just returns the information it's found. So it's found methane at 100 meters, 185 and 54 meters at Tackleston. So what this returns is a search results object, and this has some helpful function methods that can be used to retrieve the data. So we've here decided to retrieve the data from 185 meter inlet, and the object that's returned similarly has some helper functions which enable you to make some simple plot leap graphs, and this is quite a nice interactive plot which can be used to highlight different areas of data you'd like to interrogate and just have a look at the data more thoroughly. So you can also pass some arguments to the plot time series function. So we updated the title, the X and Y axis labels, and added a unit to the concentration there. You can also plot all of the data. So if you want to retrieve all the data, say if you want to plot all of the methane data from a site, so this is from Tackleston, you can retrieve all the data, and this returns a list of obs data objects. Now, obs data objects just contain all the data in an X-ray data format, and the methane and the metadata, that's associated with that data. And now this just creates a plot using our plot time series function. So here we can pass in a list of obs data objects or a single obs data object, and you can just compare the different inlet heights, and similarly as we did above, you use Plotly to make these nice little interactive plots. We can also compare different sites. So here we can search the object store for all of the methane data. So at the moment we've only got data from Tackleston and Billsdale, but we can pull the data down from these 2 sites. So we'll select the lower inlets. We've selected the 42 meter and the 54 meter inlets, and then we can use that to retrieve both the data for both those inlets. So if we do a retrieve all in the next cell, that'll retrieve all the data. So we'll have 2 obs data objects, one for the Tackleston data, one for the Billsdale data, and we can then pass that to the plot time series function and give it a title. So here we've got plots for both sites, so we can compare between the different inlets at the different sites, and as we did above, use Plotly to zoom in and have a better look at the data. And you can also double click on the plot to zoom out, as we just done there. And at the end, you'll find a tompdir.cleanup call, and that just deletes the temporary information that we've created in the object store. So I hope you found that tutorial helpful. And yeah, please look out for more of the tutorials that will be coming up soon. Thank you.